China showed a humanoid take a shove, slide across the floor, and spring back by design. Unitree's G1 debuts anti-gravity mode, fusing depth cameras, 3D LiDAR, and high-torque joints to predict impacts, brace smartly, and stand almost instantly. This isn't a stunt, it's a reliability leap. In minutes, we'll explain how it works, what the demo proves, and why it matters. Unitree's anti-gravity mode isn't magic, it's timing. The G1 keeps a constantly updated picture of the world using a depth camera plus 3D LiDAR, then moves before an impact fully arrives. In practice, that means shifting its center of mass, twisting its hips, widening its stance, or taking a fast corrective step so the disturbance never becomes a full fall. Public specs help explain why this works. The G1 is a compact humanoid, about 1.32 m tall and roughly 35 kilograms, almost equals 77 lb, with high-torque electric joints distributed across the body, enabling quick bursts of power for bracing and stand-up motions. Unitree has shown G1 configurations in the 23 DOF range, along with dexterous hands, while highlight videos demonstrate athletic maneuvers powered by these motors. For perception, media briefings and product write-ups have referenced a Livox Mid 360 LiDAR and an Intel RealSense D435 depth camera. Exact modules can vary by build, but the takeaway is a robust, 3D view of the surroundings and the robot's own motion state. That perception feeds a controller that anticipates where forces will go and routes them through stronger joints, think knees/hips, while planning a clean recovery path. The net effect is visible in slowdowns of the demo, pre-impact leaning, controlled landing, if needed, and a single, confident push to stand. Finally, the economics matter. Unitree positioned the G1 with a $16,000 base price at launch, aggressive for a capable humanoid, making it realistic for labs and pilot industrial deployments to iterate on behaviors like recovery without breaking budgets. The stress test footage shows distinct behaviors that add up to credible robustness. In a side kick, G1 throws its legs wider, rotates the pelvis, and rides momentum back to center. No flail, no freeze. During a double shove, you can catch a split-second mid-air adjustment followed by a tidy landing and an immediate stand. After a running kick that sends it sliding, the robot briefly looks with LiDAR/depth, selects a clear patch, then performs a clean, single-motion get-up instead of a multi-stage scramble. Those moments are the signature of anticipation, not just reflex. The robot is shaping the disturbance rather than passively enduring it. Multiple independent clips from the past week reinforce the pattern. Under varied hits and angle, the controller blends pre-impact posture changes with post-impact recovery plans, keeping cycle time short between oops and back to work. Equally important is what the demo doesn't certify. There's no publicly posted mean time to recovery, no standardized force thresholds, and no durability data across surfaces, wet, dusty, footwear-like contact patches. The scenes are indoors with controlled lighting and predictable friction, appropriate for a reveal, but not a blanket guarantee. That said, the behaviors align with current research progress in push recovery and disturbance-robust control, including recent work that blends locomotion and recovery into a unified learning plus control stack, some of it validated directly on G1 class hardware. So, treat the video as a capability snapshot. It demonstrates anticipate brace recover under meaningful shoves and kicks on a flat floor, and shows the controller can chain recoveries without a human reset, but broader benchmarking, third-party tests, messy environments, payloads, fatigue over hours is the next step. Reliability is the headline. In labs and pilot factory cells, tiny mishaps can snowball. A bumped robot falls. An operator has to pause work, reposition, and restart a task. With G1's recovery playbook, the robot absorbs the hit, stands up by itself, and resumes compressing interruptions from minutes to seconds. That shift directly affects uptime, safety, and human trust. When people see a robot recover gracefully, they treat it as a steady teammate rather than a fragile demo unit. The perception control stack also matters for training. Reliable disturbance handling means you can run more repetitions with fewer manual resets, accelerating skill learning and evaluation. Cost context strengthens the case. The G1's $16K positioning made serious humanoid in the loop testing attainable for universities, startups, and integrators. Orders of magnitude cheaper than many legacy platforms. And in mid-2025, Unitree unveiled the R1 at 39,900 yuan, $5.6, 5.9K, signaling a broader price-down strategy across its lineup. Even though R1 targets a different use case, those price signals suggest the company is normalizing advanced balance and recovery features at consumer-adjacent price tiers. For stakeholders, that changes planning. Disturbance robust humanoids no longer sit on distant roadmaps. They're candidates for near-term pilots in inspection, light assembly assistance, R&D automation, and education. There's also an ecosystem effect. Highly viewed clips of a compact humanoid taking hits and carrying on reset customer expectations. The conversation evolves from "can it walk?" to "what's the duty cycle, safety certification, and ROI?" The metrics that drive procurement. G1's form factor, about 1.32 m, 35 kg, and sensing suite, LiDAR plus depth camera options, make it practical in tight workspaces without the logistics of a full-size platform. If third-party benchmarks confirm robust behavior across messy conditions, anti-gravity mode stops being a party trick and becomes a line-item requirement, a resilience layer buyers expect by default. That's how one demo becomes market gravity. Anti-gravity mode turns the G1 from a cool demo into a dependable partner. It anticipates trouble, absorbs the hit, and gets back on task without a reset. That's the real breakthrough. Less downtime, more trust, and a faster path from pilot to daily use. What's next? Independent benchmarks across messy floors, longer duty cycles, and safety certifications. If those boxes get checked, resilience won't be a bonus feature. It'll be the new baseline for humanoids. Thanks for watching. If this sparked ideas, drop a comment, like, and share. Your support keeps these deep dives coming.